Hello everyone. Today we are going to discuss about the decoders. So in this series of combinational logic circuits, we previously discussed about the combinational circuits, arithmetical circuits. Then we discussed about the multiplexer and demultiplexers. Today we are going to discuss about the decoders. So decoder is a logic circuit which converts n-bit binary input data, not output, input data into the 2 raised to n output lines in such a way that only one particular output line is activated for one possible combination of a input. So based on these 3 input, any one dedicated line will be activated. So this kind of structure or this kind of logical structure is known as the decoder. So let us discuss about the 2 to 4 decoder. So in decoder, your input lines will be always n. So your input lines will be n and your output lines will be 2 raised to n. Maximum output lines can be 2 raised to n. In some applications like binary to BCD encoder, we use less than 2 raised to n lines. So maximum lines can be 2 raised to n. So here our inputs lines are A and B. So these two are the inputs, and 4 output lines D0, D1, D2 and D3 are the output lines of the 2 to 4 decoder. So let's see a truth table and a logic diagram for the 2 to 4 decoder. So as we seen that we have two input lines A and B, and we have 4 outputs D0, D1, D2 and D3. So as per the truth table, we have a 2 raised to n possibilities. So we have a 2 raised to 2. So total 4 possibilities will be there. So when input is 0, 0, then we will get a D0 as an output. When input is 0, 1, we will get a D1 as an output. When input is 1, 0, then we will get D2 as an output. And when both the inputs are high or 1, then we can get a D3 as an output. So as you can see, in decoders we'll get outputs in a form of diagonal, right? So it is very easy to remember the truth table of the decoders. So based on this truth table, we can write the logical equations. So for the first instance D0, the logical equation will be a bar dot b bar, as both the inputs are 0. So we are connecting D0 as a bar dot b bar, right? So D0 is connected to the a bar and b bar. For the D1 purpose, the logic will be a bar dot b. So D1 logic a bar dot b. So this is an a bar and b. Similarly for D2, the logical expression will be a dot b bar. So it is connected to the A and dot B bar. And for D3, what will be the logical equation? Yes, for D3 our logical equation will be A, right. So this is a D3 instance, so in D3 both the inputs are high. So A, one instance will be A dot B. So for this we connect it over D3 to the A and B. So this is about the decoder. We discussed 2 to 4 decoder, and this is a truth table and logic diagram of 2 cross 4 decoder. So let's revise today's lesson again. So basically a decoder is a logic circuit which converts AND bit binary inputs data into the 2 raised to n output lines in such a way that only one particular output line is activated for one possible combination of the input. Right. So here we are driving the output lines based on the input. So these are the input lines 1 to n, and our output lines will be 2 raised to n. Maximum output lines will be 2 raised to n. So output lines are denoted as the 1 to n. So in 2 to 4 decoder we have a 2 input lines and 4 output lines as a D0, D1, D2 and D3. Different book uses different notations. Like for inputs they use for these inputs A and B they use I0 and I1, and for output they use O0 to O4, O3, but the concept is same. Whatever notation you are comfortable with, you can use it. And this is a truth table and logic diagram. Next lecture we will discuss about the 3 to 8 decoder, which is also known as a binary to octal decoder. Bye. Have a nice day.